YouTube, this is Tom with TK Designs. Wanted to welcome you back to the channel if you've been here before, and if this is your first time visiting, thanks for stopping by. This is going to be a two-part project, starting off with the full CAD and CAM of what I'm calling the USS Ranger cribbage board full building process. Follow along with me now and we'll get through this, and don't forget to hit that like and subscribe button. For our project, we're going to start by creating a new file, and for the size plug that I already have cut for this, I have a width of 391 millimeters, a height of 225 millimeters, and a thickness of 35 millimeters. I always like to go from the lower left-hand corner, and I set my material to cherry because cherry is the wood that we're going to be using today. So we'll start that off. Next, we're going to import our vector, and I've already pre-designed this vector and made sure that it's cuttable on my CNC. If you saw my post on YouTube, you saw that I had posted a picture of the results of that. So we're going to open that up. We're going to press F9 to center that. And now we're going to start creating our vectors to determine the size of the board. Our first vector we're going to create is going to be the size of our workspace, 391 millimeters wide by 225 millimeters high. I'm going to give it a 30 millimeter radius so that it has a nice round corners. We're going to create that vector, close that off, highlight the vector, press F9 to center that. Next, we're going to make an offset vector for the interior that we're going to use to align the holes for our cribbage board. Normally, you could offset from this main vector. The problem we have with that is that if we do an offset, I like to go about 30 millimeters in. If I do that and I do the offset, it gives me sharp corners. I don't like these sharp corners. I want it more rounded. So instead of doing an offset vector, I'm going to create another rectangle with a 30 millimeter radius to match the outside. This time our width I'm going to put at 361 millimeters by 195 millimeters. Create that, close, highlight that, and press F9 in order to center it. So now that we've got our vectors created, we're going to start creating our cribbage board holes for the gameplay. For that, we're going to create holes with a radius, or I'm sorry, a diameter of 3.175 millimeters, which is about 1/8 of an inch, standard sized peg hole. And we're going to try to line that up about right in the middle. Close it, and then we're going to make copies for the number of players. In this case, we're going to go 4 players, so we're going to be doing Control C to copy, Control V. Then we're going to move that on the Y-axis 5 millimeters. Gives a good enough spacing in order for you to be able to have pegs side by side without bending or breaking the peg. So we're going to repeat that process a couple of times to get our 4 players. Control C, Control V. Go back, offset the Y position by 5 millimeters. And then for the last peg hole, we're going to select our original, press Control C and Control V to copy and paste it. This time we're going to move it a negative 5 millimeters on the Y-axis to move it down below. Close that out. Once we're done there, we're going to highlight our 4 peg holes. We're going to come over here and group them. We need to group them so that they'll copy properly along the vector when we decide to make the holes. So Now that they're grouped, I'll highlight, double click, and we want to move those to where they line up centered on that interior vector. Okay, so now that we've got our initial set of holes laid out, we are going to highlight that interior vector along with the 4 holes. You do that by holding the shift key and clicking the interior vector. Then we're going to do copy along vectors and create 150 copies aligning the objects to the curve. Make sure you select align objects to the curve so that they go around the curves of the vector. So we'll go ahead and say copy, and when our copy is complete we can click on close, and now we no longer need that original set of peg holes. So what we will do is we will leave those highlighted, press the delete key, and now they're gone. The next step in the process is going to be to put a little bit of spacing between our pegs, so we have our starting position, our stop position, and can clearly identify our scoring. We usually break these up into groups of 5. Alright, so I'm going to start by deleting this group of 4 pegs under the E in Ranger. I'm going to move over 2 to the left for my start position. Go 1 more over, delete that, and then every 6th set of holes we're going to delete so that we have groups of 5. So we'll count them out: 1, 2, 3, 4, 5, 6. Delete. 1, 2, 3, 4, 5, 6, and delete. And for the rest of these, I will speed up the video as I go through and delete. And the pegs will be our finish direction. So with that, we're going to highlight that group. We're going to ungroup them, and we're going to delete 3 of the holes because we don't need to have anything but a singular hole. We're going to move that down, trying to line it up in the middle between these 2 pegs, and then we're set. The last step we want to take prior to creating our tool paths is to create the pegs for winning out the game. So what I'm going to do, I'm going to come down here and copy this group of 5. Control C, Control V to paste, and we're going to drag that up to about the middle of the board here, and then rotate it 90 degrees. And we'll take the last 2 groups here, copy and paste, because we should go up to 7. Line those up, and then finally one last row, and we're going to ungroup that and leave just 1 hole. And we'll move our winning hole to center between the 4 holes and move it up. Now, before we can do our tool paths, there's one last thing that we need to do in preparation, and that's to make our mirrored image of our inlay. We're going to need to do that so that we're able to create both the pocket and the plug. So by mirroring it, that makes the plug side. Now, in order to do this, the first thing that I like to do is I like to make a separate sheet with the size of what my inlay is going to be. In this case, it's going to be approximately 165 millimeters by 165 millimeters, and it will be about 16 millimeters thick. For our material, that's going to be walnut. And go ahead and get that started. So now, when we scroll out, we see that we have two sheets. You can double click back to sheet number 1, and we're going to highlight all of our inlay. Right click on that, and we're going to copy to sheet 2. Now if we scroll out and scroll back in, or double click on sheet number 2 and scroll in, we'll see that we have our copy of our inlay. Now in order to make this work, we have to mirror this. So go back on the drawing tab after we've highlighted everything. We're going to click the mirror selected objects and then mirror it to the right. Then we can press F9 to center it on our sheet. Now from there, we need to make sure that we can make an exact opposite of it, so we're going to add one more vector in. And in order to do that, I'm going to select everything, and I'm going to do an offset vector of 10 millimeters to the outside. That will give us the ability to make the male plug. Go back over to our main sheet and we'll be ready to start with the toolpaths. Now that we've completed the board design, it's time to move on to our toolpaths. I'm going to do these toolpaths starting with the V-Carve inlay, both the pocket and the plug, and then I'll move on to the remaining toolpaths that are necessary to complete the board. So starting with the pocket side, we're going to highlight our ship's crest, click over to our toolpaths, and do a V-Carve toolpath. We'll have a start depth of 0.0 millimeters and a flat depth of 8.0 millimeters using our speed tool W01005 engraving bit used that's actually a tapered ball nose bit. We will use a pass depth of 3 millimeters, a speed of 18,000 RPM, and a feed rate of 600 millimeters per minute with a 300 millimeter per minute plunge rate. Same specifications will be used for the clearance tool that we're going to use, a 1/8 inch end mill. We'll go ahead and we will name that as pocket. Calculate that out, and we'll see we have our pocket side ready to go. I'm going to change the colors to where we're going with a color somewhat similar to walnut color. Let's see if we can get something closer to a brown. And set the same color for our pocket, and we will preview the toolpaths. Alright, so there we have our pocket side of the V-Carve inlay. Now that we've completed the pocket side of the inlay, we're going to go and do the plug side of our inlay. So for that, we need to switch over to sheet number 2 and then go over to our toolpaths. We're going to select everything, and we're going to do another V-Carve toolpath. Now with this, we're going to do a start depth of 7.5 and a flat depth of 1.5. What this is going to do is this is going to give us about a 1.5 millimeter glue gap and gap above the board, which we'll be using the CNC to remove later in the process. So something to keep in mind is that with the hobby CNCs, we can't go to this depth. Looking at this tool path, the CNC will assume that our start depth is already cleared material, and it'll plunge all the way down to 9 millimeters. We don't want to do that. So we're going to make this as our third tool path, actually. So we're going to call this plug 2. And we'll calculate that all out. And then if we actually run it, that'll be our full depth. But we're not going to do that full depth on one particular tool path because obviously we would crash our bit, probably break it, and possibly damage our CNC. So we'll reset that preview, go back over to our 2D tool path, close that, and now we're going to create a second tool path called plug, and we're going to set that one at 4.5 with a flat depth of 1.5. This will give us a basic depth of about 6 millimeters in depth. We're going to call this plug number 1. Calculate that out. And then we're going to drag above our plug 2 settings. And we'll go ahead and close that out. And then we'll make our main plug, which is going to be starting off at 2 millimeters in depth and going down to a flat depth of 1.5. This will give us a total depth of 3.5 millimeters, and this will be our first pass. So we're just going to call that one plug and calculate that out. Move plug up above plug 1 and plug 2. And now if we do these tool paths in order, and it's important to do them in order because when we group these and export them later, they will execute in the order we have them. But we're going to start with plug clear, and you see that goes just about 3.5 millimeters in. Then if we run plug 1, it's going to take us down to our depth of 6 millimeters. Then finally plug 3 is going to take us all the way down to our 9 millimeter depth. Now this is just the 1/8 inch end mill at this point. After that we'll do a tool change, and we'll start with plug with our V-Carve, and as we see, it'll do a pass. Execute plug 1, takes it down, and then plug 2 will complete out our entire plug side. We will, with the bandsaw, clear off the excess material so that we can glue this up. So now we can go ahead and close that out. Switch back over to our file operations and our 2D toolpath, and go back to sheet number 1. Next, we're going to need to do our toolpaths for our cribbage board peg holes. So for that, we are going to use a drilling path. But we need to start by selecting all of our peg holes. Okay, now once we've got our peg holes selected, we'll go over to our tool paths. We're going to do a drilling tool path. For the drilling tool path, we're going to go down to a cut depth of 12.7 millimeters using a 1/8 inch or a 3.175 millimeter end mill. We will use peck drilling and retract above the cutting start depth. Our retract gap will be 0 millimeters and our peck depth will be 2 millimeters. What that will do is allow us to go down 2 millimeters, pull our tool back all the way out of the hole along with any of the debris that's in the hole from our cut, and continue down 2 millimeters at a time until we hit our 12.7 millimeter depth. I have chosen that depth because that depth gives us the ability to get a nice fit with the pegs that I purchased for this project. We'll go ahead and we will call this peg drill, and we'll calculate that out. And there we have our tool paths. Now if we select all three of our tool paths and click preview, we'll see we have our board and all of our peg holes now cut. So we'll go ahead and close the toolpath preview, move back over, switch to our 2D tab, and we have one more toolpath that we need to create right now, and that is our profile toolpath. For our profile toolpath, we're going to highlight that outside vector, and we're going to do a profile toolpath. Now for our profile, I plan on using the bandsaw to edge or to cut around these edges. So we're going to give a path for us to follow. Instead of going the entire 35 millimeters in depth, which is difficult to do because I only have about 4 inches of play in the Z-axis to begin with, what we will do instead is we'll go down about, we'll say 25 millimeters, which is around 1 inch. For our tool, we're going to use a 1/4 inch end mill. And we're going to set that at about 18 inches per minute and a plunge rate of 9. And our pass depth will be about one-eighth of an inch. We'll go ahead and select that. And we're going to make sure that our vector is along the outside. And we'll call this profile. Calculate that out. And now, as we see, we'll go most of the way through the board, but not all the way through the board. We execute that toolpath. We'll have a little bit that we can take off with our bandsaw, and then we'll clean it up with the palm router afterwards to keep those edges. So that wraps up part 1 of our 2-part build video for this cribbage board. Thanks for watching. If you want to catch part 2 where we do the actual assembly and cutting, please like, subscribe, and set the bell notification, and join us for part 2, which should be coming out in a couple of days' time. Again, thanks for watching, and see you next time.